Hello everyone. In this video, we are going to discuss the assignment one of distribution system engineering. So this assignment is based upon the data provided. So this is a smart meter data obtained in the city of Mathura in the year 2021 in the month of January and February. So the meter readings are obtained at each and every timestamp at an interval of 3 minutes. And the data obtained consists of the energy reading, which is in the kilowatt hour, and the voltage and current and the frequency and the meter number. So there are total 35 number of meters, and the meters are named as MH01, MH03, and so on. The numbers are not in the sequence. Like after MH01, there is MH03, then MH04, 5. Some MH0 number is maybe missing. So total 35 number of meters are present there. And as you can see, some of the times the voltage reading is obtained as a zero. So there are two possibilities for that. One is that zero voltage means there is a service interruption. The supply may have got disconnected. And another possibility is that the meter is not giving the outcome, even if the supply is connected there. So it is because of some fault in the meter. So what we are going to do is that assignment asks you to discard that data where the voltage reading is zero, treating that as a missing data. Further, in the month of January and February, for which the data is there, all the meters are not present all the time. So some of the days, some meters are absent. Some of the days, some meters are present. So we have to take care of all those things. Now, let us see what exactly the assignment is asking to do. So, first step is we have to read the data from Excel file into MATLAB and discard the missing data based upon the voltage. So, wherever voltage is zero, we need to discard that data. And now, whatever available data is there, based upon that, we have to calculate some factors or some numbers for that smart meter reading data. So we will first do step one and we will see how we can proceed ahead. So I have put in a single folder the given Excel file, and I have created a new MATLAB file here. So as a good practice, let me clear all the previous data in the workspace if it is present and close all the figures. So that will just for clearing the things. And now I will read that Excel file into MATLAB workspace. So for reading the Excel file or the CSV file, there are multiple options. So first option is the XLS read is one of the command. In the newer MATLAB version, XLS read may not work. Sometimes it may work, but like as the MATLAB version increases, that XLS read command is not recommended. Another command is read table or read matrix. So let us try both. I will show both the methods and then we will see. So I will store that entire data of the Excel sheet in a single variable as a matrix or a table. So let me give that as a name data, and let me use first command in the read matrix. So inside the read matrix, file name I have to give. So file name is, I will just copy from there. Uh, so the file name dot CSV. Okay, and I'll just put a semicolon so that the result should not be displayed. So I will run this much and let us see what happens. So a data got created, which is if I open that data in the MATLAB workspace, you can see. So there are six columns, and uh, that six columns are displayed there. All the data has come. But you see first and sixth column. If you see in the Excel file, these are not the numbers. The first column is the data present in the date time format, and the last column, which is meter, that data is present in a, that is not a number, that is in the form of a alphanumeric alphabets and numericals. So MATLAB is not able to read and understand that command, so it is showing as a NaN stands for not a number. So read matrix is not a good idea to use. So let us try another method, which is read table. So let me execute that. And you can see now the data is created. If I see that it is created now as a table, and now you can see the column headers, the titles of the column are there, and the timestamp data and meter data, all the data is present as it was there in the Excel file. So this is a good, this seems to be a good idea to read the data using read table command. Now going ahead, what we have to do, we have to replace that data where the voltage readings are zero. So if I open the data, voltage readings I can see in the column number 3. So there are multiple ways to do this task. Where voltage reading are zero, we need to discard that data. So I can use a if else, like for each and every row of that data table, I can see in column 3, if it is zero, then I will completely eliminate that row. So in MATLAB, we can eliminate by putting empty matrix as a assigning that row as a empty row. So that is the way. Another way, so we can write a for loop for each and every row, and then if else condition, like if that third column is zero. That is one way of doing it. Another way, in a simple manner, we can easily do that, where which is called as a logical indexing in MATLAB. So let me first check I will show display how to do that. So we have to check for column 3. So data, and this is a, when you type data dot, here you can see the titles of the columns are displayed. So I have to select out of that the voltage, and I have to check whether that is equal to zero. So by writing that, I am getting a I am writing specifying a condition. So suppose I want to execute this command, I will select it, right click, and you can see evaluate selection in command window. So the shortcut is F9 that you can press. So if I execute that, you can see the answer appearing in the command window, and that consists of uh, zeros or ones. Okay, so sometimes it is zero, sometimes it is one, as you can see. So when that condition is satisfied, there one is displayed, otherwise not. So whenever there is a one, that means the voltage is zero, that means that should be treated as a missing data. So that row has to be declared as a empty matrix for all the columns. So how should I do that now? I should do that like this. So I will select the data, and the row is selected from this condition, and I have to select all the columns, and that I have to declare as a empty. Right. So now you see the original data consists of how many number of rows? It is 550560. So that is around 5,50,560. But when I execute this code, I get the number of rows as reduced one, which is 4,83,965, which is reduced one. So this is doing the job. So this is basically uh, discarding missing data where voltage reading is zero. Okay, so that data we have discarded. Fine. So first step we have completed, where we have to read the data, and second step also we have completed, where the missing data based upon the voltage reading zero, that we have to discard. Okay, so we'll proceed further. The code should give following output. So we have to calculate minimum, maximum, average KVA load connected to the individual meters. And the next task is also the minimum, maximum, average kilowatt loads connected to the individual meters. So here we want KVA and kilowatt values. And in the data provided, what we have is kilowatt hour in the second column, and in third, fourth column, we have voltage and current. So we can calculate kilowatt by dividing kWh by hours. And as already discussed in the class, or you can see clearly from the data, every data is available for 3 minute duration. So 3 minute corresponds to 3 by 60 hours. So when I divide each and every sample point, like column of the column 2 divided by 3 by 60, that should give me the kilowatt. So I will create another column, which let us say seventh column, which consists of the entry kilowatt, and eighth column, which consists of the entry kVA. So kVA, how can we calculate? It is simply voltage into current divided by 1000, because the voltage is given in volt, current is given in the ampere. So kVA we have to divide by 1000. So in MATLAB, how can we do that? So it's like this. So data, I have to create another column. So I will specify data dot kilowatt, and that has to be calculated as a data dot the kilowatt hour, that existing kilowatt hour data. We have to divide that by hour. So hour is 3 by 60. So that will give the corresponding kilowatt reading. And similarly, I can create data dot kVA, that is data dot voltage. So this is the voltage column. We have to multiply that column by current. So now voltage is a column and current is a column, and we have to do element by element multiplication. So there we should use in MATLAB dot star, that represents element by element multiplication of two vectors. So that is data dot. Uh, so here you see there is the current, this is the current, and this needs to be divided by 1000. That should give me the kVA readings. So I will execute that, and now you see the number of columns are increased, and seventh column I'm getting kilowatt reading, eighth column I'm getting a kVA reading for each and every time instant. Fine. So that's what I'm getting. Okay. Kilowatt kVA we got, but what we have to calculate? So the question says minimum maximum average value connected to individual meter. So meter wise we need to calculate, and so we need to segregate that data meter wise. For example, MH01, the kilowatt readings and kVA readings we need to separate out, and from that, out of that, mean, max, and average we have to calculate. So here we require a loop which basically runs for each and every meter, for I equal to each and every meter. So what kind of what meters are there? So here in the Excel file, you can simply scroll and see one by one what MH0 or that meter code is written here. That is one way. Or simple way is in the Excel file, you can create a filter here. So you can go to this and create a filter by, and you can see here. So you can see there is a MH01, MH03, MH06, MH07, and so on till MH47. So these are the meter readings. So one way is manually tell to MATLAB, for MH01 do this, for MH02 do this, for MH03 do this. Okay. So manually we can write it. But there is a command in MATLAB which identifies what are the unique set of values or unique set of strings present in the given column. So that we need to identify. So basically we are interested in this data dot, which column we are interested in, where the meters are specified. So data dot meter. So if I display that much, so I will execute this command by selecting and pressing F9. So you can see there, I'm getting the readings as MH01, but it's basically that Excel column I'm getting. But I need to identify what are the unique meters present in this uh, set of data, this column. So in MATLAB, there is a command called unique. And when I execute by pressing F9, I am getting the numbers. And it is also telling that it is of size 35 by 1 array. So that means there are 35 unique meters, like MH01, MH03. Okay. And that information, this is basically giving the information of unique meters present in our data set. And I will assign that name so that we can use it later, which is meter. Okay, fine. And we have to, as discussed, we have to run the code for every meter. So I will assign a number I equal to starting from 1 to length of the meter. So I know that the number of meters is 35, but if tomorrow, suppose I give a new Excel file, the data would change. and there may be 40 meters, I don't know, there can be 20 meters. So we need to automate the code. We need not every time manually enter the value. Okay, so the code will automatically recognize what is the length of the meter. So if you just run that length of the meter command, any okay, meter, okay, I need to execute this first and then check what is the length of the meter. That gives me number 35. So the code will run for each and every meter I equal to 1 to 35. That's all. Fine. Now, what is the next task? Just focus on that. Okay. So here, so we need to calculate the kVA and kilowatt. So the data is already present in the column number 7 and 8. Just we need to get that data. So what we need here is for individual meter wise, we need to extract the kVA readings. So what I will do is inside that, I will define a vector called as kVA underscore meter. So that is giving the answer meter wise. So where should I look that data for? In the data.kva. So data.kva, that column. And here I need to put a condition that I don't want all the data, but I want that data for which the meter is the ith meter. So how should I write that? It is basically the conditional logical or the I'm putting a condition and condition on the index, right? So if I see in the data what I have to do exactly, I want the eighth column which is kVA, but I don't want all the readings. I want to see in the meter column if that meter is MH01, then select only that kVA. So that's how I have to do. So let's do that in MATLAB. So here we have to put a condition that if this meter column that is equal to MH01, which is ith meter. So it is a string, it is a like character, it is not a number. So in the MATLAB there is a command called as for string comparison. There is a command called as strcmp. So how does that work? Let me show in the command window. See, focus on the command window. So strcmp, stands for string compare. Okay. So if the two strings entered in that are same, for example, I will put some random string like xyz, and I will put another random string which is pqr. So it is comparing the both the strings, and when I enter, it is giving logical zero. So that means the both the numbers are not equal. But when I do the same thing, like when both will be equal, both the strings will be equal, it is giving logical one. So it is giving a logical answer, whether zero or one in that sense. So I will use the same concept here. String compare. So which strings I have to compare? The meter column. So that is data dot meter. That I have to compare with the ith meter, like that. Okay, and that should give me the kVA present in the meter. So I will just display this before going ahead. I will display this for only 1 meter. Okay, so I will execute only this command and let us see what it gives. Okay, so it is giving some kVA readings, some number of kVA readings for that meter, for entire data set. Okay, only for that meter. And you see that kVA meter is 9597. So there are 9597 number of data, which is for meter one only. And I have to calculate out of that the all the values like minimum value, max value, and average value. Okay, so let's calculate minimum value. So I denote it, let me denote that by kVA underscore mean. So minimum of, so it is basically minimum out of that kVA underscore meter. Okay, so let us just execute this minimum of this. So it is showing as a 0.0028 as a reading. Fine. So that reading it is showing. But sometimes you see. Okay, let's focus on the. So minimum non-zero value we have to select. Like sometimes there can be a service interruption, like or not service interruption, like voltage is present, but there is no power consumption happening. So it can give a zero reading also. Like you can see in the maybe here should see. For example, here the voltage is 270 volt, but corresponding kilowatt hour energy consumption is zero. So under that scenario, KVA reading can be zero. So we have to select a non-zero value. So I will put another condition there because I have to select only non-zero values, that KVA underscore meter is not equal to zero. Okay, so I'm making sure that only non-zero values are selected. Now, in the similar fashion, I can calculate kVA max equal to maximum out of all the readings, which is kVA underscore meter. And coming to average, so this is kVA underscore AVG. I will type. So in the MATLAB, you can calculate average as a mean of all the readings, say kVA underscore meter. Now here one important point, that so average value usually we define as the energy consumption divided by total duration. So here we know that all the data are sampled at a uniform sampling rate, which is 3 minute, and whatever available data is there, like excluding the non-available data or the missing data, we are taking all the data into account. So the mean is same as calculating the energy divided by total duration. Okay, just because all the data is sampled at a uniform sampling rate, which is 3 minute. So that's why we can calculate the mean like this. Otherwise, we could not have calculated. So this is for I equal to 1, that is for first meter. So let us execute that and let us see how kilowatt values we are getting. So you can see that minimum kVA, max kVA, and average kVA, those values are getting there. And we can do the same thing for all the meters. So if I enable the loop, I can get the data for all the meters. Okay, so let us do it first for only 1 meter. Now the same thing we have to do for kilowatt also. So I'll just copy and paste and replace kVA by kW. So kVA should be replaced by kW. Other things will remain as it is. Other logics and all. Okay, so this that is for 1 meter. I will run again, and you can see that kilowatt average, kilowatt max, and kilowatt mean, those values are getting here. Okay, I did a mistake. And here it should be kilowatt, right? Otherwise, it could not give zero value. Yes, so KW minimum is 0.02, max is this, and average is this. So you can see in workspace the data is appearing for meter number 1, and that has to be done for all the meters. So I will enable the for loop where it will run for all the meters and data will be we will be getting. Now, how to represent that data? So many data we have. So how many data we have? So for each and every meter, 35 meters, we are getting three value for each meter. So not three, actually six. So kVA minimum maximum average, those three, and kilowatt minimum maximum average. So basically six readings for every meter. So we can store that as a matrix, or we can store that as a table in the form of a table, such that rows represent meter and column represent the corresponding kilowatt mean max average and kVA mean max average. So we have to put this data in the form of a table. So just for like a proper representation, so that we can read that data easily. So I will create a table, say T1, and how to create the table in MATLAB. So we need to create a table bracket. Okay, so inside that bracket, what has to be there? We need how many columns? So we need one column for meter, and another six columns for like kW minimum, kW maximum, kW average, kVA minimum, kVA maximum, kVA average. So initially, when we initialize the table before starting the for loop, we will initialize that as a empty columns. So empty column. So all the seventh column we have just said. So seven empty columns we need to initialize. So 4, 5, 6, and 7. And we need to give the names of the variable, like names of the variable in the sense like what each and every column is indicating. So we need to type the variable names. So first name will be meter. We need to display which meter it is. Then second will be, so all this variable name has to be written in a curly braces, inside the curly braces, like that. Okay. Then we have KW, KW minimum, then KW max, and that sequence does not really matter what sequence you put the data. We are just interested in the data. Okay. Then KVA min, then we have KVA max, and finally KVA average value. And as the loop runs for each and every meter, the data will get updated in the table. So I will have to rewrite the table inside the for loop once again. So we'll just do that. So when all the data has been calculated, I will just redefine or rewrite the table. So we have to basically append from the existing table T1, we need to append in the next row. So just try to imagine. So the first reading is meter I, ith meter that we are displaying. The second reading will be KW minimum. Then next reading will be KW max and KW uh, average. Then we have KVA readings. Okay, so the data should get updated, and I will run that once again so that some error some end is missing. What is that? Okay, for loop is empty. Okay, okay. The table needs to be closed. Okay, like that. So now you see in the workspace the 35 by 7 table is created, and you see the table consists of column saying meter mh01. It's KW mean max average value, KVA mean max average value, and like that for all the meters the values are stored there. Okay, so this completes our uh, first two parts of the question. So all the values are now represented in the form of a table. Okay, now there are some other factors that we need to calculate. So going ahead, daily load factor, non-coincident demand of the distribution transformer, diversified demand, and diversity factor. Okay, so these things we need to calculate. Now, out of this, what we can immediately calculate from what we have just calculated right now. So we can actually calculate the non-coincident kilowatt demand. So what is a non-coincident kilowatt demand? It is the sum of individual meters maximum demands, and which that data is stored in where? It is stored in the KW max column of the T1 matrix or the T1 table. So if I can sum all those maximum demands, I will get the non-coincident demand on that transformer, because all the meters, they are like those are serving some homes, and those homes are getting supply from a single distribution transformer. So that's why I can calculate the non-coincident demand of that transformer just after this. So other data will require something else to be done. But let us calculate non-coincident demand, which is simply sum of the matrix or the table T1, and out of that I need to select which column, KW max column. So let me just execute that, and I will get a NCD as 74.64 kilowatt. So that is the non coincident demand of transformer, or in short, or distribution transformer, or DT. Okay, fine. Now NCD is done. So we have completed this part also. Okay, now let's go to another things. So daily load factors and diversified kilowatt demand and diversity factor. So now we have calculated NCD. We need to calculate the diversified demand. So let us first complete this part. Then we will go to other parts. Diversified kilowatt demand. So for that, what we require? So here we require at each and every time step, what is the load appearing on the transformer that we need to calculate. And for each and every time step, we know that not all the 35 meters are present simultaneously. Some of the meters may be absent someday. For some time, some of the meters are absent. So for each and every time step, we need to basically run a loop. So we will calculate the kilowatt value as seen from the transformer. And once we calculate that, we need to select the peak of that out of that kW value, and that will give us the diversified demand on DT or the DD value. And once we get the DD value, we can calculate next the diversity factor, which is nothing but NCD divided by DD. So let's do that. So this for this we require not meter wise, but we need to see the individual time step wise. Okay. And now what time step is available? Like what time we need to consider? So here, how many time steps are there? So here the data is given for month of January and February, some particular days where the meters are present, and every 3 minute data is available. But not all the meters are present all the time. So that is a kind of tricky part. So let us not focus on what all meters are present. We need to bother about the what unique time instances are present. Okay, so likewise, earlier we have selected unique meters and run a loop for individual meters because we wanted the data for individual meters. So here what we do, now we have to focus on individual time steps. So let me create a separate section here to calculate the distribution transformer loading. And here we need to identify how much unique time steps or instances are available. So in the data, that x underscore time step that I will select, and I will assign some variable name to it, say unique time UT. And if I execute that command, you can see that UT is time step like date time table or date time vector consisting of the dates and corresponding time which are unique. So you see the data is 4,83,000, but the unique time instances are 24,480 only. Okay, because at this time maybe meter 1 is present, meter 3 is present, meter 5 is present, meter 10 is present. So the data is getting repeated. So that's why that number is unique time is number is reducing. Okay, so once we identify the unique time, now we need to run a loop for each and every unique time. Okay. Now, so for let us say I equal to 1 to that length of unit time, like what we did earlier, the same kind of programming we are doing here. Okay, now here what we have to do, we have to calculate the kilowatt of transformer, kilowatt as seen from the transformer. So we need to select the data dot kilowatt, and here we need to put a logical indexing. So logical indexing in the sense, I don't want all the kilowatt data, but I want that kilowatt data for which the time instant matches that ith unique time instant. Okay, so suppose I will open the data set. Now consider this. The time step here is 2nd of January 2021, 00:57 minute. So at that time, what is the KW? That value, this it will pick up. Similarly, it is for meter MH01. the similar value will be available for say another meter mh06 for example, and there some kilowatt value is present. So I will pick up that value. Similarly, say another meter mh05, that value, and all the meters wherever it is present, it will pick up that value. So okay, so here data dot time step, if that time step is matching with the unique time of ith instant that we are considering. Okay, so let me just execute that command. So now select, let us say, in the command window, what I will do, I will select the first time step. So let us say I equal to 1, and we need to see what is unique time of the first. It is 1st January 2021 000 hours. That is the time. And now let me execute this command. Okay, the where the data is matching with the unit time. So what this should give, this is a condition, so it will give either 0 or 1. Wherever it is present, it will 1, otherwise 0. And I will pick up the kilowatt wherever it is 1, that kilowatt I will pick up. So I will execute this total, and I get the data. So it is, you can see it is just a 20 numbers. So 20 number of meters are present at that time. Other meters are not giving reading, or they are maybe power consumption is not there, I don't know. So that data may be missing. So 20 number of meters are connected. We don't bother here about what all meters are connected. That specific we are not bothered about. So, and the transformer loading will be sum of all those readings. So if I sum it all up and execute that command, uh, okay, and so okay, so that is giving as a 2.96 kW, and that I need to uh, store. Okay, so that I will store as kilowatt on the distribution transformer of that ith time instant. Okay, I'm storing that here. Okay, and once we, okay, so let me execute that section. Okay, so for all the time instant, it will do, and it is taking some time because there are so many around 4,83,000 time instances. Sorry, unique time. So it is 24,480. So that many times the code will run, and then it will store the data. So it is running, and it may take some few minutes. And once this gives the kilowatt data, we need to find the peak of that data. That will give the DD, and NCD by DD will give the DF. So you can see the code is running. Meanwhile, the code is running. I will write what I just said. So I have to calculate DD, which is same as maximum of kilowatt underscore DT. That entire column, maximum value it will pick up. And so this is diversified demand of DT. And I have to calculate the diversity factor, which is NCD divided by DD. This is diversity factor of that distribution transformer. Okay, so the code has run, and you see that KWDT, that value is created as a vector. So if I just plot it, you see how does that look like. So that is indicating with respect to time how the demand on transformer is fluctuating. So it is seriously fluctuating between almost around 0 point something to around approximately 17 point something kilowatt. So there is a huge fluctuation, and the peak, uh, so peak value DD, I will execute that command. So that will calculate the DD. So DD is coming as a 16.72, and the DF, which is the ratio, that is coming as a 4.4641. That is the diversity factor. So we just calculated the last two. Okay, so this part of the assignment is done, and the first two questions are done. And what remains is the next thing, which is daily load factor of individual meters for every available day. So here, for this is little bit critical. Like we have to do calculation for all the meters. So there is a for loop for every meter, and we have to calculate the best. We have to make the calculation for each day. So we need to select for every month, for every day. So there will be like a three cascaded for loops running. One for loop for month of January and February, another for loop for day, and another for loop for individual meters. So those like three cascaded for loops will run, and there we will calculate the thing, the load factor that we have to calculate, and also we need to arrange that in a particular manner. So I will just create another section for that, and here we have to calculate what like daily load factors of uh, meters. Okay. Huh. So as I said, for every day we have to do it. So I will run a for loop for each and every month. So we have 2 months data, January and February. So this for loop is for Jan and Feb. Okay, because we have 2 months and end the for loop. Inside that, we need another for loop for day. So we know that January has a 31 and February has 28. So we can simply write 31, no problem, or we can do like to make the code so uh, something like if the month is 1, then the how many maximum days are available in the January is 31, and else if month is February, second month, then maximum available days will be 28 for 2021. So that thing we can write, and for every day we can run a code like this. Okay, now here again we need to select every meter. So again for I equal to 1 to lengths of meter. So that we have done already previously. So this is for each day, and this for loop is for each meter. Okay, so inside this, whatever code we are writing, that we have to write. So again, simply the same thing, logical indexing. So what we have to select, load factor we have to calculate. So we need the data of kilowatt. So we need data dot kilowatt, and here we need to put a condition that the time stamp, its month has to be the M, its day has to be the D, and meter has to match with the ith meter. So that condition we will put that will give us the kilowatt of that particular day or that particular meter. So I'll put those condition. So the month of data dot that timestamp. So if that month matches with M, okay, I'm writing a condition. So month command that gives the month, whether it is January, February, like in the form of 1 or 2, it will give that. So that is one condition. Another condition I have to put. So I will write and day of data dot timestamp that day, if that is D, and there is another condition, the meter. So here we will use the string comparison as done earlier. So what we have to compare, data dot meter has to be compared with the ith meter. Fine. So that will give me the kilowatt of that day, right? And once the kilowatt of that day is obtained, so what kind of data is this? How many readings will be there? So for every day, every 3 month, the 3 minute, the data is obtained. So the data will be 24 hours into in each hour 20 data. So 24 by 20, 24 by 20. That many kilowatt underscore data will be available. And out of that, we have to calculate the uh, average and maximum, and average divided by maximum will give the load factor. So I will define a load factor as the average value of that kilowatt day divided by max value of uh, kilowatt day. Okay, so that simply gives us the load factor. Fine. So let me run that section and see if it is working or not, or anything wrong we have done. Let us see. So again, there are so many days, so it may take a time. Yes. So now things are running, and let us see whether it is. So I will stop in between. Hmm. Let us see first. So what are we getting actually? Kilowatt and LF. So LF we are getting some value. Kilowatt day 480 values we are getting. How come we are getting 480 values? Because so the total number of data should be 20 multiplied by 24 as discussed earlier, 24 hours in a day, and every hour 3-minute interval we are getting data, so that is 20, so 480 numbers we are getting, so that is fine. So sometimes you can see that data is absent, so it is giving the zero reading. Sometimes it may be present, so it is giving like that. So data set we are getting, and LF also we are getting. Now we can just go ahead and run that loop, but we also need to basically store that data in some table, right? So we need to arrange the data. Let us think about that, how we can arrange the data. So again, as let us arrange that in the form of a table. So uh, there are multiple ways in which it can be arranged. So like table like month, comma day that we can store, and meter we can store, and corresponding load factor value. So let's store in that format. There are other fancy ways of doing it also, but let us begin with a very simple thing, and then we can proceed. Okay, so what we will do before starting all the loops, we need to declare a empty table, right? As we did earlier. So let us declare a table T2 as a table, and how many, like what variable names we want there, that we need to write. So first of all, we need to declare what month it is, then what day it is of that month, and which meter we are getting the value, and corresponding uh, load factor value. So that four columns we need to have. So I will create a four empty columns, one, two, three, and four, like that. And once this table is created, we can just append that table. So I'll just copy this, and inside the loop, once the things are calculated for each day, we need to append the table. So T2 is equal to the previously calculated table. Inside that we have to append, and the table needs to be closed. And here, so those four values are, so we are denoting month by M, day by D, and meter by meter bracket I, and the LF value. Okay, like that. And that table will be created then. So this is how it will work. So let me run that section again, and let us wait because there is a huge amount of data. It may take few minutes again. Okay, so here we are getting error. The error says concatenating the table variable LF using what get resulted in variable of wrong length. So let's see what LF value we are getting. It is empty. LF value is empty. Why? Because LF is calculated based upon KW underscore day. That value is empty. That means probably that day, like meter is not giving any data. That can be the reason. Or it is a missing data. So data is not available for that time instant. So what we can do, so what is the problem? So it should leave it empty, right? But since we are putting the data in the form of a table, the table recognizes that as an empty size, which is not matching with the table size. So that's why the it cannot read that, or cannot append the write the data in the form of a table. So here we will put a condition, like if else we can put something like that. Like when the kilowatt day is empty, like say if is empty is empty. So that will check whether the kilowatt underscore day, that data is empty or not. If it is empty, then we will declare the load factor as sum, not a number. Okay, we will just else if it is not empty, then it has to be calculated by this formula. And okay, so we are putting now a like conditional statement. And now let us execute that section and see. So I will just stop, clear the all the things first. CLC, and now execute that section again, and let us see whether the table T2 gets created or not after the end of this execution. Since data is large, it's taking time, and now we are not getting error till now. That means probably that if else logic is working. You can see on the left corner of this here, it is showing busy. That means it is still running. And you can see this pause option. That means it is still running. When it completes, it will indicate. Okay, now that busy of that gone, and now the run option is going, pause option gone. And now T2, you can see it is 59 cross 4 table. So let us see what it is showing. So for month one, day one, the meter this, and we are getting LF. Okay. Um, oh, something wrong happened. Only meter 47 we are getting. Did we do anything wrong? 1 to length of meter we have done. Anything wrong? This is for every meter. Okay, okay, okay. Ah, so the wrong what we have done is that this is for every meter. So it has to be inside the meter loop. So for I equal to meter, inside that loop, we need to write this table. Okay. So this before ending the loop. Okay, we'll just sorry. Yeah. So what wrong we have done? Like after this for loop end, we have written that table update, but we have to update the table inside that loop only, so that for every meter the things should get updated. And now I will run again only that section. So now see it is showing busy on the left corner, and here it is showing pause option. That means it is running. Again, few minutes it will take. So in total, the loop is running for, okay, now it has stopped. The loop is running for 31 days of January, 28 days for February, and there may be some missing days. So and for each day, for every meter. So we have 30 plus approximately how much? So 31 plus 28, and for every day we have 35 meters. So the data is around 2065. So T2 size will be 2065 and four values. So four values, what are the four values? The month, day, meter, and load factor. So 2065 by 4. That table is getting created here. So day one of the month one, for MH01, there is no load factor. That means it's absent. For MH01, the MH03, this is the load factor. MH06, this is the load factor. Like all for all the 35 meters till MH047. Now then in the second day, we are again getting this data. Okay. So you can play around that data, arrange that data in a systematic format and so on. But here is what we are getting as a final answer. So we have just calculated the daily load factors of all the meters based upon the kilowatt values. And this is taking only the available readings only, since we have put the condition there. So this stops. So here we will stop. The next assignment on this will be based upon the same data set, but here you have to apply like calculate some other factors. So that's it for this video, and we will